What is up, everyone? In this video, I'm going to give you another example on how to refactor stuff, on how to refactor basically production grade code. I'm going to refactor some code in my Hollywood framework, which is an actor model framework. It's the fastest one on the planet, basically. And there is some, of course, not completely in a stable release yet. And I found something that's not correct, and I'm going to refactor it. And I think it's better than giving you sometimes all these simple small tutorials that you basically can find all around YouTube. So I'm going to give you some kind of a live coding thing. I'm not quite sure how I'm going to solve it, but then you can see my thinking process and all that stuff, right? But before we're going to do that, consider subscribing to my channel if you're not already. Give me a thumbs up, leave some questions in the comments, jump into my Discord community. And for the people that really want to know how I built this thing behind the scenes, how you, like basically real life stuff, you can go to my Patreon page. There's a lot of cool stuff there, distributed file system, blockchain stuff, all in Golang. Also, yeah, basically all in Golang, all high level engineering stuff. Check it out, let me know what you think about that. All right, let's go. So basically, I'm in Hollywood here, in the master. And there's a problem in something that is called poisoning an actor, right? Let me open up engine. See, poison is a function basically, and what a poison does is if you poison a process, right? An actor model is basically some kind of a programming paradigm where you have these actors, which are basically small encapsulated processes that live asynchronous from each other, and you can send messages and all that stuff, and it solves a lot of big problems. But that's maybe a video for later, and I also discovered that in previous videos, right? Well, and you can read a lot of the actor model if you really want to know what it does and why it's good, right? So basically, the poison is where you want to stop a process. And if you think about it, really the underlying semantics, a poison basically sends the process, right? You have a pit and you want to poison that pit, you basically want to stop it. You're going to send to that process what is called a poison pill. You're basically you're gonna kill it. You're going to give him a poison pill, he's going to eat it, and he's going to die, right? And the way I implement this was very lazy, right? If you see what I did, what I did is basically you poison with the pit, right? This pit here. I get the pit from the registry. Then I check, of course, if the process is not null, which basically means that we find something. We're going to send basically just a stopped message here, and that's actually a callback. Let me open up. Do I have examples actually to show you? It doesn't actually really matter. We're basically going to send this stopped. It's something that your process will receive, so you know that your process is going to stop, so you can do some stuff, right? It's kind of a callback, a notification basically. And then we're going to call proc shutdown. And if we call shutdown, it's an interface, of course. That's going to be... that's a good question. What is shutdown here? Let's look it up. Shutdown is basically we're going to close the quit channel, right? And if we close the quit channel, it's basically this big loop here. Try restart and all that stuff. Is this loop here, where we listening for messages here, and if we got the quit channel, then we're going to close the inbox and we're going to break the loop, right? There's a big problem here, right? Because that's not the semantic I want to implement. What I want is that if your process is running and another process or yourself or whatever is calling poison, you want to stop it, the first thing I wanted to do is to process all the messages in his inbox, in his queue first. It's not going to be a hard stop. It's going to be, because in actor model, everything is kind of fault tolerant, everything is kind of graceful. That's some of the semantics here. And I'm just basically hard shutting down. The only thing I do is basically set the stop message, and then I'm just shut down the inbox, and nothing going to happen anymore, right? So what we're going to do is, and actually I'm thinking about something. Like I said, it's an unscripted version to show my thinking process on how I'm going to do this without breaking the whole shebang. Let me quickly check if it's true what we're telling it here, because we have this inbox thing, and if we quit, we break the loop. Yes, so if we break the loop, we actually cannot receive anymore from inbox. That basically means Yes, it's true. So what we're going to do, instead of closing this channel, we're basically going to send a poison pill. We're going to make a message, which is going to be a poison pill, like it should be. We're going to send it, and it will basically be, let's say what's happening right now, right? So let's show it. Let's say you have a process, right? A proc, and this proc has an inbox. And this inbox has, let's say, message 1, 2, and 3 to process. Right, we're gonna process that. We're gonna actually call receive on this message. Right, that's what's gonna happen in your receiver. You will see later on if you make a test. And let's say he's processing 3, and then it's done. 3 is done, but then you send a poison. Then you call poison. What's gonna happen is you're gonna shut this down. Right, nothing is gonna happen anymore. The only thing it's gonna receive is basically a stop message. Right. That's the only thing it's going to receive. But 2 and 1 will never be received. That's not what I want. What I want, basically, is, let's delete this here. What I want is that we have 1, 2, 3, maybe 4, or 5, or 45, 54. We process this message. We send a poison pill, which basically means that this poison pill will be here. Poison pill, PP. The PP. Poison pill will be here. So it's going to process 3, process 2, and of course there could be messages here, right? It could be, I don't know, 44 could be here, 33 after the poison pill, right? But we're going to process these messages first, the last messages in the queue before we send that poison pill. Then it's going to receive this poison pill, and then it's going to send the stop message, right, and kill the whole loop, right? And of course, 33 and 44 will not be handled anymore. That's the goal. And we're already 7 minutes in, and I didn't do anything. But it's very important because it's just important. You need to know. I mean, it's like I said, it's time for some in-depth content, right? I mean, life is not a pony camp, right? And YouTube is a pony camp, and we're going to change that. We're going to deviate. Like I said in my streams, we're going to deviate from from what's happening in the world. Right, so how are we going to do that? Actually, I think it's not going to be that bad. Do I have types? Yes, I have. We have a dead letter event. Yeah, that's all fine. That's all fine. Initialized and all that stuff. Internal error spawn event. What's that? I don't think I'm using that, to be honest. Termination event, internal error. Am I using this? Yes, I am. Am I using this, actually? No, we don't. Get them out of here. So we're going to make a poison pill. The question rather is, do we want poison pill to be... I don't think so. We're going to say poison. How do you write poison? Poison pill. Going to be a struct. Do we need to have some... I don't think so. I think poison pill is fine. So what we're going to do is in engine here, like poison, instead of sending the stop message, and I'm going to basically, what I'm always doing is in refactoring is I'm commenting out, holy shit, what I had, and then I'm going to add something new, and I'm going to keep it in. It's like a small versioning inside of your code, so you can easily go back and see what's going on. It's a small thing. It's my habit. It's maybe not the best, but it helps for me. So what we're going to do is we're going to say E. We're going to send a local message, right? We're going to send that to the pit we want to poison, and we're going to actually send a poison pill. That's what we're going to do. Poison pill, of course, null, because there is no sender. We could actually do a system, but it's fine. It's fine. We're going to send this poison pill. So, of course, let me open up one test here real quick. Actually, to be honest, let's get it back here. Let's open up an engine test. Test poison here. Let's kill these windows here real quick. So, another thing that I actually noticed is that this test is garbage. This test poison, if I run this, is going to work, but it's garbage, right? And the reason why is because... First, let's, this new test producer, I can get rid of it because I have something like new implemented. This is basically, you can spawn processes as funcs also, right? So we can spawn a function. It's going to be a func c actor. Actually, we don't need an actor here, just context because we are inside of our own package. I cannot type because the font is so big. We're going to call this process test, and the tag is this one. That's fine. So what's going to happen here is this process gonna spawn. We're gonna poison it, and then we're gonna check if it's still in the registry, and it shouldn't be because it's poisoned, so it should be deleted. Problem is that it's gonna poison something. It's just not synchronous enough to test. Everything is in an actor model. Everything is very async, and this test is just not good enough. So what I'm gonna do is I'm gonna make a Ouija, which is gonna be a sync wait group, right? And each time we are in this loop, we're gonna say Ouija add 1, right? And then what we're gonna do here is we're gonna if underscore OK is going to be the context message. We're gonna cast this to if it's an started, right? And that's OK actually, just like that. So what this is going to do is each time a process is getting started, we're going to send a started message to the process, and each time we receive it here, we are going to say Ouija done, right? Ouija done. So we 100% sure it's in the registry and everything is booted up, and then we're going to wait here, Ouija wait, and we're going to wait, and then we're going to poison it, and then we're going to check it. That's what we're going to do. And if I run this test right now. The reason why I know this is because I had some other tests that do the same mechanic and it's just not good, and I changed it, but this one I didn't change, right? So now you can see we started this process, pit local test 0, it started test 01, we're going to shut down 0 and then shut down 2, and where is the shutdown of 3? Nobody knows where it is, but it's fine. Let me quickly see. Right, it's fine. Let me do it again. Actually, I'm confused, to be honest. This is a cached version, a cache test. It is what it is. It's annoying, but it is what it is. All right, so what we're gonna do? We're gonna refactor this. We're gonna open up engine. Sometimes weird things happen, black magic and witchcraft and such, and you just need to accept that, right? So we're gonna stop this thingy here. Actually, what I should test here is that if you have a poison thingy, that stop is basically triggered. That's something what you should do. So we're going to send a poison pill to this process. Right now, if I run this test, it's not going to work anymore, I guess. Actually, it is. It's so annoying. Yeah, of course, because we have this proc shutdown here. We don't need this proc shutdown, and we don't need this remove registry. The reason why this is working is because poisoning itself is also async, right? And that's why maybe 3 didn't come up. So everything is very, very, very async, non-blocking actually, to be honest. So if we send this poison pill, nothing's gonna happen, right? Because look at this, it's gonna completely whine, right? Because the test is working. So what we're gonna do is we go into our process here. And instead of here where we see this message, what we're going to do here is we are going to say that if, we're going to say if underscore, okay. We could do a switch, but that's not good. We're going to say env message, if that's, so annoying this VS Code, if that's a poison pill. Actually, to be honest, we can do it like that. Okay. What we're going to do here is, well, there's a little bit of an issue here, right? Because look at this. Can we quit ourselves? What we could do, and because we're going to send ourselves a message, but we're going to close the inbox. So that's not going to work. So what we could do is basically do something like this. Can I close my inbox here? That could be dangerous. We're gonna close the inbox. That's fine. So we cannot send messages anymore, but we could do something like a receive, directly call it. We could do something nasty real quick. I'm gonna refactor this, no worries, just to make it work. P context. And then break the loop. So if we see this, we could actually do this. Always set the message. Actually, that's not true. Look at this. Instead of setting the message to, it is a poison pill, right? We don't need to handle a poison pill. We could do a stop message. Receive it, break the loop. What do you think about that? Isn't that clean? Of course, the sender could always be the sender, right? Look at this. It's already clean again. All right. Not quite sure if that's something. It's it could be something, right? Let's test this. Let's go to engine, test. Yes, I'm not quite sure what I need to expect from this, to be honest. What's going on here? Actor dead ladder. Actually, it's a process test. It's not. Oh yeah. I see. Yeah, I see. So the problem is that we also need to... We cannot shut it down here. And process self, I don't think I have access to... Because if I do a proc shutdown, it will trigger quit, right? This is cleanup. Oh yeah, this is... We clean it up here. I see. Okay, so the problem with this test is going to be that if we poison here, it's going to be an asynchronous way. Look at this. If I'm going to sleep here, that's so annoying. If I'm going to sleep at a time second here, this might work. How clean is this? Yeah, so the problem is here actually. This is so clean. Look at this. Started, shut down. Started, shut down. Yeah, the problem is, guys, that this poison is going to send a message, right? That's the only thing it does. It's going to send... We don't need to shut down. We don't need to remove because it's getting cleaned up. We don't need to send a stopped because it's getting stopped probably. How are we going to test that? We're going to check that... Let's do a switch here, to be honest. We're going to say switch message. It's going to be C message. The type. Then we're going to say case started. Like this. And then we're going to say case stopped. Like this. We're going to do a VG done on started. Delete this guy. And it should be the same thing. Of course, MSG is going to be a problem. So we're going to say FMT Let's do a quick print, which will not help testing things, but it is what it is. So let's test this right here. You see, we get this stop message each time. Look at this, how clean. Look at this, how clean. We could do something like, to be honest, something like this. Just for the compiler, right? Make it happy, satisfy it, just like your girl or your husband. You need to satisfy. We need to satisfy two things as an engineer: the compiler and our spouses. How do you say that? The first time I use this word in all my life, to be honest. All right, so you're gonna say received the stop message. This is so clean that it's illegal. Trust me. Look at this. Boom. Receive stop message. Boom. Receive stop message. Boom. Boom. Perfectly fine. So how can we test if poison actually works like it should be? That's by this is basically a wait it needs to do for it started. That's fine. And then we're going to poison it. And then we're going to sleep. So what we're going to do is we're going to make a stop VG, which is going to be another sync wait group, which we're going to add each time we start it. That's amazing, man. We're going to add one each time we start, and we're going to stop this message. Fuck this message, man. We're going to stop VG DOM each time we are in stopped. We don't need to switch on this message. We don't need it. Which is basically, we're going to wait here until we start it. What's going on here? Okay, started was this switch. Fine. And each time we poison, instead of doing a nasty time.sleep, we're going to say stop VG done. Wait. Before we're going to assert if it's actually gone. Is this going to be something? To be honest, is stopped, are we 100% sure that if you are stopped, that we actually remove it from the registry? That's also not quite sure, right? Nasty little things going on. Is this cached or what is this? Just do some anti-caching. I think this is gonna work, by the way. Started, shut down. Started, shut down. Started, shut down. Started, shut down. Hey man, this is beautiful. Beautiful. Look at this with all these wait groups. Perfectly fine. Let's do a var here. Let's make it clean. Boom. Delete the space because... Alright. And now we're gonna quickly check, process real quick if it's actually nice. So we set the sender here. And I need to be very careful that the code is not inside of my camera window, or people on YouTube are gonna cry, right? They're whining. They're basically depressed because my code is behind my camera. Can you imagine? P-context sender is fine. Then we're gonna check if it's a poison pill. If it's a poison pill, we're gonna close the inbox. We're gonna set the message as a stop message. We're gonna directly receive it without sending a message to the channel because we are gonna close it here. Then we're gonna break the loop here. So we're gonna clean up here, which basically means we're gonna clean up here. We're gonna remove it from the registry, do some parent stuff, yada yada, check for children, shut down, send a termination event. And we're done. Look at this. Beautiful, right? So let's do, how do you call it? I don't know. We're just going to test everything. We're going to make test, which is basically going to do async race condition test and everything. And you see that we failed, right? Once in a time. What is this? What is failing, actually? Look at this nasty shenanigans. Race, yeah. This race, there is one race condition that's actually not a race condition in a test. It's probably this. Oh, it's test poison. Oh. What a plot twist, guys. What a plot twist. Man, you thought we were done. And look at that. Look at that. So what I'm gonna do real quick is, it's 24 minutes, so annoying, man. The problem is I wish my videos could be so long, but the problem is that people have an attention span of a goldfish, so yeah. What's going on here? So what I'm gonna do is I'm gonna actually run this test with a race flag real quick. Yeah, data race. What is this? This is weird. We write here. Where do we read this then? Man, why is that? Is it because it's not a pointer or something? Since weight groups are basically problematic. What's going on? This is something. It's a race condition in a test. It's not a race condition in a system, right? It's just I don't understand why this is. Is this bugged? Stop VG. Wait, why should and I make these nasty things going on. Maybe. It doesn't really matter where I do it. Well, that's weird. It's very nasty, very weird. Actually, it fixed itself right now. Okay, it's fixed. Maybe it has something. I added this weight group after we done here. Maybe that's because this is an async call, right? The spawn func is somewhere else. Actually, that could be a race condition. Never thought about that. It's very strange because you need to understand this is a callback, right? This callback is getting spawned in another routine. But still, anyway, it doesn't matter. Sometimes you need to don't think about things too deep because, yeah. Guys, look at this. What's this test? The spawn child. Yeah, I know about this one. I need to refactor some tests because, like I said, a lot of these tests are working without weight groups and they work with time sleeps just to synchronize between when things are basically, and sometimes it's faster and sometimes it's slower, and that's basically determining if the tests are gonna pause or not. So I need to make sure that's fixed, right? But that's out of scope. So this is basically how I approach things, right? A little bit of thinking process, try here and there, do some comments, do some tests, and yeah. And if you wanna, if you never heard about the actor model, check out Hollywood on GitHub. The link is in the description. Check it out. Try to break it. Give me some information if there's something you need, so I can make it better if there are some bugs reported. And of course, if you like the videos I'm providing to you, please consider subscribing to my channel if you're not already. Give me a thumbs up. And hey, guys, listen, you don't need to subscribe and you don't need to give a thumbs up, but you need to go into my Discord channel, right? Because people smart enough already subscribe, right? Hey, and check out the Patreon if you really want to level up as an engineer. And I'll see you in the next live stream or the next video. Bye-bye.